Welcome back, everyone. We're looking at homework 4.2, and we've actually gone through this already. We talked briefly about the conceptual questions, number 1 through 4, and I have them written out here in case you want to rewrite them again. And we did go through questions 5 through 8 in class as well, but I figured you could possibly benefit from another video review of questions 5 through 8. So here they are. We're going to start with number 5. Again, 1 through 4 are already finished for us. They're just conceptual. But we'll start with 5 and go 5, 6, 7, and 8. So question number 5, we've got a baseball theme here, and we've got a press box. I'll draw that in black right here. Press box, and we have a reporter in the press box right there, and he is 32 feet above the ground. All right, so we'll say that's the ground right there, and this is 32 feet down to the ground, and the ground being horizontal extends out this direction right here, and our reporter friend sees second base, which is, we'll say, right there. In fact, I'll make that black because that's an important object. Second base. Right there. And we were told that he sees it at an angle of 15 degrees below the horizontal. So if this is horizontal right here, let's try that again. Oh, heck with it. Yeah, my horizontal isn't very straight. You know what? I'm just going to erase it, draw it again. If that's our horizontal, then the viewing angle is 15 degrees below that. So that's horizontal. And our reporter is looking down at second base at 15 degrees below the horizontal. Which means, of course, we've just completed a right triangle right here. If this 32 feet is perpendicular and if the 32 feet is vertical and the ground is horizontal, we've got a perpendicular junction here, and of course that's going to be a square or a 90-degree angle right there. But if this angle here is 15 degrees, then that should also mean that our angle down here is 15 degrees as well, because after all, these are what we call opposite interior angles. So this is horizontal, the ground is horizontal, and we have this line of sight bisecting it. These two inside angles are going to be the same. And I don't know what that was right there, but anyway, so we've got 90 degrees and 15 degrees, and what are we trying to find? We're trying to find the horizontal distance, and I'll write it as h right here. This horizontal distance from directly below our reporter friend to second base. Okay, he's 32 feet up in the air. What is that horizontal distance? Well, let's take a look at our sine functions here. If you recall SOHCAHTOA, that means sine of an angle is opposite over adjacent. The cosine of an angle is adjacent over the hypotenuse. That's this right here. And the tangent of an angle is opposite over adjacent. So in fact, I should have just written out the tangent. Oh, I'll do it right here. You know, I'll write them all out. What the heck? You can just skip over this if this bores you. Cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over the adjacent. So we have an angle right here. We've got 15 degrees angle. And let's look and see what our sides are with respect to it. If this is our angle, 15 degrees, then 32 is going to be our opposite. So opposite equals 32 feet. And what are we trying to find? Our adjacent, right? We're trying to find h right here, which is the adjacent to the 15-degree angle. So the adjacent equals h, which is what we're trying to find, the horizontal distance. And we'll say our angle right here is 15 degrees. That's an awful big degree sign. It looks like 150, doesn't it? 15 degrees. So which sine function would we use? We have an opposite and an adjacent and an angle. Well, that looks like tangent right here. We would use that because tangent of an angle is opposite over adjacent. So let's write it down here. Let's go down below here. So the tangent of what angle are we using? We're using 15 degrees right in there. Tangent of 15 equals opposite over adjacent equals 32 over the side we're trying to find, which is h. Well, let's solve for h now. We want to multiply both sides by h, and that means h will come up here, but we want h by itself. We don't want it times tan 15, so we're going to divide both sides by tangent of 15, and that'll come down to the bottom right here. So really, our final equation is going to be our horizontal distance here equals 32 feet divided by the tangent of 15. Now, before we calculate this out, you want to make sure your calculator under the mode button is set to degrees, not radians, because after all, this is 15 degrees we're talking about here, not 15 radians. And if you have it set on radian mode, that'll give you a wrong answer. But if we take 32 and divide it by the tangent of 15, whatever that happens to be, that will give us our distance h. And h turns out to be 119 feet. Again, make sure if you get a wrong answer that your mode is set to degrees, not radians, because that's 15 degrees right there. But if you take 32 divided by tan of 15, you should get a horizontal distance of 119 feet. Let's move on to question number 6.